Assalamualaikum warahmatullahi wabarakatuh. Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Alhamdulillah, pada kesempatan video kali ini kita bertemu kembali untuk mata kuliah Robotika. Jadi pada sub bahasan kali ini atau pokok bahasan kali ini, pertemuan ini kita akan berbicara terkait dengan klasifikasi robot. Jadi di video sebelumnya kita tahu bahwa banyak sekali ternyata yang dapat dikategorikan sebagai robot, ya. Ada robot humanoid, ada robot beroda, ada robot wheel, dan seterusnya itu. Nah, di pertemuan kali ini kita akan nanti bahas terkait dengan klasifikasi robot, ya. Kemudian untuk klasifikasi robot ini kita gunakan video dari Robot and Its Type, ya, Classification of Robot dari Simtel Robotik. Ini sumbernya dari YouTube, ya. Yang kita saksikan bersama untuk videonya. Video terkait dengan klasifikasi robot.
Scientech presents Simtel's technology learning software, robotics. Robotics is the branch of technology that deals with the design, construction, operation and application of robots and computer systems for their control, sensory feedback and information processing. A robot is a mechanical or virtual agent, usually an electromechanical machine, that is guided by a computer program or electronic circuitry. Robots can be autonomous or semi-autonomous, and range from humanoids, such as Honda's Asimo and Toshi's Topio, to industrial robots. Let's start with types of robot. Robots can be classified into two broad categories, that is robot by locomotion and robot by application. First, we discuss about robot by locomotion. The shape of a robot is the most basic approach to define a type, and it is relative with its locomotion system. These type of robots are shown in an animation. Now, robot by application, it is a hybrid system, can be used to perform an application's task. So in this type, we don't care about shape, and there are various applications of robots in industry, home and also in military. In robot by locomotion, first is stationary robots. There are various types of stationary robot as we see in animation. We will discuss each, one by one. First we take Cartesian robots. Typical Cartesian robots have three linear axes of freedom, which are perpendicularly oriented at each other. Because of their rigid structure, this type of robots usually offer good levels of precision and repeatability. Next is cylindrical robots. The cylindrical robot has three axes of movement, two of which are linear and one is circular. So usually robots of this type can move along Z and Y axis and rotate along Z axis. Cylindrical robot used for specific handling and assembly task, or spot welding. Now, spherical robots. Spherical robots, sometimes regarded as polar robots, are stationary robot arms, with spherical or near-spherical work envelopes, that can be positioned in a polar coordinate system. Next is SCARA robots. The SCARA acronym stands for Selective Compliant Assembly Robot Arm, or Selective Compliant Articulated Robot Arm. Its arm was rigid in the Z-axis and pliable in the XY axis, which allowed it to adapt to the holes in the XY axis. Another one is articulated robots. An articulated robot is a robot with rotary joints. Articulated robots can range from simple to jointed structures to systems with 10 or more interacting joints. They are powered by a variety of means, including electric motors. Parallel robots. A parallel manipulator is a mechanical system that uses several computer-controlled serial chains to support a single platform or end effectors. Perhaps the best-known parallel manipulator is formed from 6 linear actuators that support a movable base for devices, such as flight simulators. Next type of robot by locomotion is wheeled robots, which are most popular among the consumer market. Their differential steering provides low cost and simplicity. Types of wheeled robot are shown in animation. We will discuss each, one by one. In this, first is single-wheeled. One-wheeled robots are extremely difficult to keep balanced, due to the single point of contact with the ground. A single-wheel robot could be a cheaper solution for a robot receptionist, who has to work on one floor only. Next is two-wheeled robots. Like one-wheeled robots, two-wheeled robots are also harder to balance than other types, because they must keep moving to maintain upright. The center of gravity of the robot body is kept below the axle. Usually this is accomplished by mounting the batteries below the body. Next one is three-wheeled robots. In this robot direction may be changed by varying the relative rate of rotation of the two separately driven wheels. If both the wheels are driven in the same direction and speed, the robot will go straight. Another one is four-wheeled robots. Four-wheeled robots are more stable than the three-wheel version, since the center of gravity has to remain inside the rectangle formed by the four wheels, instead of a triangle. Next is five or more wheeled robot. The Mars rovers are six-wheeled robots that navigate across Martian terrain after landing. They are used to examine territory, interesting landmarks and make observations about the surface of Mars. They have a suspension system which keeps all six wheels in contact with the surface. Tracked robots. A tracked vehicle is a vehicle that runs on continuous tracks instead of wheels. Tracked vehicles include construction vehicles, military armored vehicles and unmanned ground vehicles. The principal design advantages of tracked over wheeled vehicles are that they are in contact with a larger surface area. Another type of locomotive robot is legged robot. It can be classified into following categories as shown in animation. We will discuss each, one by one. First is one-legged robots. In 1980 and 1993, there was a lot of research in making one-legged robots at the Massachusetts Institute of Technology. Leo NXT Hopper and Toyota's robot are the example of the one-legged robot. Next is two-legged robots. Two-legged robots have probably seen the most development dollars, since humanoid robots have been envisioned since the very beginning of the field. The design of a bipedal passive dynamic walker begins with the concept of a wheel with spokes. Now, three-legged robots. Three-legged robots are statically stable, since there are 3 contact points to ground. For a robot to be statically stable, it requires a minimum of 3 contact points to ground. Now, four-legged robots. Four-legged robots have the advantage of being statically stable, when not moving, but require dynamic walking control. Boston Dynamics has developed a four-legged robot, 4D, RPA, called Big Dog. They claim that this is the most advanced quadruped robot on Earth. Another one is 5 or 6-legged robots. A hexapod robot is a mechanical vehicle that walks on 6 legs. Since a robot can be statically stable on 3 or more legs, a hexapod robot has a great deal of flexibility in how it can move. If legs become disabled, the robot may still be able to walk. Robots with lots of legs. As we can see from nature, centipedes have a great level of trafficability. The count of legs, as well as the length-to-width ratio of a creature, can be accounted for this ability. That's why centipedes, along with other creatures, are researched and imitated. Next type of locomotive robot is swimming robots. Swimming robot is an ocean data service provider. It is an autonomous, environmentally powered ocean-going platform for gathering and remotely transmitting information about the surface of the ocean, such as water temperature, and the atmospheric conditions above, such as wind speed. Another locomotive robot is flying robots. Flying robots use various kinds of technologies. We will group these robots by their flying system, such as air balloon robots, robots with rotary wings, wing flapping robots and plane robots. Rolling robotic balls. This robot is a pendulum-driven mobile spherical robot, with a fixed axis. The axis is a bit extended to provide place for cameras and other possible hardware, such as sensors, microphones or speakers. Next is modular robots. Modular self-reconfiguring robotic systems, or self-reconfigurable modular robots, are autonomous kinematic machines, with variable morphology. Self-reconfiguring robots are also able to deliberately change their own shape, by rearranging the connectivity of their parts. Next is micro-robots. Micro-robotics is the field of miniature robotics. In particular mobile robots with characteristic dimensions less than 1 mm. The term can also be used for robots, capable of handling micrometer-size components. Another one is snake robots. A snake arm robot is a slender hyper-redundant manipulator. The high number of degrees of freedom allows the arm to snake along a path, or around an obstacle, hence the name is given as snake arm. Now, we move to see classification of robots, based on their application. First is industrial robots. An industrial robot is defined as an automatically controlled, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes. Typical applications of robots include welding, painting, assembly, pick and place, product inspection, and testing. domestic robots. This type of robots includes quite different devices, such as robotic vacuum cleaners, robotic pool cleaners, sweepers, gutter cleaners and other robots that can do different chores. Also, some surveillance and telepresence robots could be regarded as household robots, if used in that environment. Next is medical robots. Medical robots are robots that allow surgeons greater access to areas under operation, using more precise and less invasive methods. They are most telemanipulators, which use the surgeon's actions on one side to control the effectors on the other side. Another one is military robots. This type of robots includes bomb disposal robots, different transportation robots, reconnaissance drones. These robots, initially created for military purposes, can be used in law enforcement, search and rescue and other related fields. Next is space robots. Space robots used on the International Space Station, Kudus, that was used in shuttles, as well as Mars rovers and other robots used in space. Another type is hobby and competition robots. These are the robots that you create, such as line followers, sumo bots, robots made just for fun and robots made for competition.
Oke, baik, tadi kita telah lihat bersama terkait dengan video klasifikasi robot beserta contoh-contohnya, ya, contoh-contoh robotnya. Jadi robot dapat kita klasifikasikan ya berdasarkan video tadi ada dua tipe. Jadi kategori untuk pengklasifikasian robot bisa dikategorikan berdasarkan locomotion atau caranya bergerak ya. Kemudian robot dikategorikan juga berdasarkan aplikasi. Jadi bisa dikategorikan berdasarkan locomotion, juga bisa dikelompokkan berdasarkan aplikasinya. Untuk robot berdasarkan locomotion diklasifikasikan ada beberapa ini, ada robot stasioner ya, kemudian ada robot beroda, robot berkaki ya di sini. Kemudian ada robot berenang, robot moduler, robot mikro. Kemudian ada robot rolling ball ya, kemudian ada juga robot ular di sini. Nah, kemudian di robot stasioner sendiri, ini robot yang stasioner. Kemudian robot by locomotion. Nah, robot by locomotion ini ada yang beberapa itu dirinci kembali ya. Nah, di bagian robot stasioner ada robot kartesian, jadi dia bergeraknya itu X, Y, Z ya di sana. Kemudian ada yang robot cylindrical, jadi bentuknya ya robot kayak ya medan geraknya itu adalah ruang seperti silindris gitu. Kemudian ada robot spherical. Nah, spherical ini setengah lingkaran ya. Jadi ruang geraknya adalah setengah ruang bola itu ya, setengah. Kemudian ada robot skara ya. Skara ini hampir mirip dengan kartesian ya, cuma dia menggunakan sendinya sendi rotari ya, jadi dia aksesnya dari atas ke bawah. Tapi kalau yang kartesian ini XY ya, dia linear pergerakannya. Kemudian ada articulated robot, ada juga parallel robot. Nah, parallel robot ini dia manipulatornya banyak, cuman ujungnya satu ya, dipakai misalnya di simulator penerbangan. Kemudian di bagian robot beroda, wheel robot ya, maka dibedakan berdasarkan jumlah kaki atau jumlah rodanya. Di sini ada single wheel ya. Single wheel ini ya kayak robot beroda satu ya, robot naik sepeda tapi rodanya satu. Kemudian ada robot dengan 2 roda, ini yang banyak dipakai di yang sekarang itu ya, dipakai di seperti bandara, itu kendaraannya sudah menggunakan robot dengan atau kendaraan 2 roda di sana. Dipakai di supermarket atau di bandara biasanya tugasnya untuk memudahkan pergerakan ya, karena kalau bandara kan luas itu. Kalau jalan kaki ya lumayan lama, biasanya menggunakan two wheel ini. Kemudian ada juga robot dengan rodanya ada 3 ya, ada 4, kemudian ada 4, ada 5 atau lebih ya. Kemudian juga ada nomor robotnya, modelnya adalah tracked ya, kayak motor tank gitu ya, atau kendaraan-kendaraan berat yang menggunakan robot dengan atau menggunakan roda juga dengan tracked gitu ya, pakai kayak semacam belt tapi yang langsung menyentuh ke permukaan tanah ya. Kemudian dari robot berkaki ini juga dibedakan berdasarkan sama jumlah kakinya ya. Ada robot dengan 1 kaki ya, ada robot dengan 2 kaki, ini yang humanoid dengan 2 kaki, kemudian ada robot dengan 3 kaki ya, kemudian ada robot dengan 4 kaki, ada robot dengan 5 atau 6 kaki ya, kan ada robot yang lebih dari 6 ya, jadi banyak kaki seperti robot lipan tadi ya. Jadi robot-robot ini sebenarnya yang meniru cara jalannya makhluk hidup ya, kalau yang sudah berkaki seperti ini. Jadi kalau yang 2 kaki bisa niru manusia ya, atau niru cara kanguru jalan, loncat loncat juga bisa ya. Ada yang 3 kaki dan seterusnya gitu. Kemudian robot-robot yang lain di kategori berdasarkan locomotion ini adalah ada robot berenang ya, ini meniru ikan ya. Kemudian flying robot ini meniru burung atau model pesawat atau helikopter juga masuk sini. Kemudian ada rolling robotic robot ya, rolling robotic ball ya, jadi bentuknya bola, dia rolling ya. Karena kalau bola di rolling ya, biasanya untuk surveillance ya, atau pengintaian di sana. Kemudian ada robot modular ya, jadi ada robot mikro ya, ini bentuknya mikro, skalanya mikro ya, sama juga ini untuk pengintaian ya, cocok ini. Kemudian ada robot yang meniru ke ular ya, snake robot ya. Cara geraknya ya sama seperti cara geraknya ular dengan merayap atau istilahnya glide atau apa tadi ya bisa. Kemudian berdasarkan aplikasinya, maka robot dibedakan atau bisa dikategorikan lagi ya, tipe-tipenya adalah ya, aplikasinya seperti robot di industri namanya industrial robot ya. Kemudian robot yang dipakai di rumah tangga namanya berarti domestic robot, ini ada termasuk vacuum cleaner, robot pelipat pakaian dan seterusnya. Kemudian robot yang dipakai di medis ya, medical robot ini yang membantu proses operasi ya, dan penanganan pasien, misalnya pengantaran obat juga masuk sini. Kemudian di bidang militer ini juga banyak yang dipakai ya, robot. Ada robot penjinak bom, ada drone tadi ya, yang pesawat ya, robot pengebom itu dan sebagainya. Kemudian ada yang robot digunakan di ruang angkasa atau space robot. Yang terakhir adalah robot untuk hobi dan kompetisi. Jadi kalau di Indonesia sendiri di tingkat nasional ada tiap tahunnya ada kontes robot ya, atau KRI, kontes robot Indonesia, ada KRCI, kontes robot cerdas Indonesia, ada KRSNI ya, robot seni dan seterusnya banyak ya. Jadi untuk hobi itu yang mainan termasuk di dalamnya di sini. Itu robot berdasarkan aplikasinya atau penggunaan atau penerapannya. Oke, baik. Untuk materi terkait klasifikasi robot, saya kira cukup sampai sini. Jika ada pertanyaan, silakan disampaikan di grup kuliah. Kurang lebihnya, mohon maaf. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.